Assalamualaikum and a very good day. Welcome to our presentation on the software group project using Studio. We are from Group 4 and my name is AINA NISHA ANMOL binti Muhammad MANSHA PERVAIZ and I am joined by my team members which is Arynna Maarof binti Muhammad ROSLAN, JINING AMIRAH binti NORDIN and also SITI AISYAH binti ADNAN. Together, we have embarked on a journey to explore the application of Studio in addressing geotechnical challenges, and without further ado, let's dive into our project. Hi everyone, today we are delving into geotechnical engineering with a focus on GeoStudio. Our objective is to tackle soil erosion and slope stability challenges using an advanced geotechnical software, and GeoStudio is renowned for its precision and reliability in simulating complex soil structure interactions, making it a leading tool in this field. And our goals are clear, which is to showcase a GeoStudio's effectiveness in the real-world geotechnical challenges and contribute to a broader engineering methodologies. And throughout this presentation, we'll cover a various sections including data collection, software simulation, manual calculation, discussion, and also recommendations. And our aim is to provide a valuable insight into a soil erosion and slope stability management within the geotechnical engineering. And let's embark on this journey together and explore the powerful capabilities of GeoStudio in addressing geotechnical challenges.
The main concern in this problem statement is soil erosion. Since soil erosion can either happen slowly and go unnoticed, it can happen quickly and cause significant loss of topsoil. Other severe soil degradation characteristics that might hasten soil erosion are compaction, insufficient organic matter, loss of soil structure, inadequate internal drainage, salinization, and soil acidity issue. Erosion risk increases with slope length and steepness in the field. Because more runoff accumulate at longer slope, there is an increase in soil erosion by water. When small fields are combined into larger ones, the outcome is frequently longer slope length with higher potential for erosion because of the increased water velocity that allows for more scouring. So these are a few examples of ways to prevent soil erosion. The first one is by using shrub and grasses. Second is by using diversion. Third is by using terrace. The fourth is by using erosion control blanket.
Okay, so our report is based on a case study of a fair slope in Fiatepilana Road, Albania. It has an inclination angle between 25 to 40 degree. So it was open in public, but a major landslide occurred after that. So the slope protection at the area were not strong and sufficient enough to retain the sliding material of the slope. So this report intends to model the failure occurring at the site. So we use GeoStudio and we assume the soil layers and parameters and later propose a stable solution for the erosion problem. So this case study is assumed to have the conditions and dimensions as below on the next slide based on the result of the SI report and borehole log. Okay, so this is the slope that we model using GeoStudio, and these are the parameters of the soil. We have sand and clay layers. Okay, so for the software output, for global shear failure, we obtain a value of factor of safety 1.634, which is okay. For local shear failure, we obtain the value of factor of safety 2.307, which is okay, but it's quite over-designed.
So for the manual calculation, first we need to calculate the effective normal stress sigma at the slash base. Sigma equals to the W times cosine alpha over the L and minus the mu times cosine alpha squared. Sigma equals to the 3.2369 kN, and the actual effective normal stress value from GeoStudio equals to the 6.4649 kN. For the total base normal, N equals to sigma plus mu times L and equal to the 4.042 kN. And actual total base normal value from GeoStudio is 8.0732 kN. And the total shear resistance S at the slice base is S equal to the C times L plus sigma times tan theta phi equals to the 3.6 kN. And then the portion of ice that is mobilized as mob is equal to the S over F ice, and it is 2.203 kN. And actual portion of ice that is mobilized value from GeoStudio is 4.3551 kilonewton.
So for discussion, we are going to see the differences between the local and global shear failure. So the first characteristic for local shear failure is the small area impact that leading to a shear plane due to weakened strength. The second one is linked to weak layers, soil variations, and irregular foundation geometry. So the third one is typically has minimal effects on surrounding soil with localized consequences. To know what is global shear failure, the first one is it includes the extensive failure zone compromising overall foundation stability. Second one, it triggered by factors like excessive loading or poor soil conditions over a broader area. Okay, the last one is it may lead to severe consequences such as settlement or tilting of the entire structure. Okay, so for our case study, which is the slope failure near to the residential areas, so the most suitable chosen FOS here is 1.5, which is the range for active land use. Active land use, it is including the residential areas. You can see the differences of the result in manual calculation and GeoStudio, which is the result of the value for GeoStudio is slightly bigger compared to the manual calculation.
Our team analysis using GeoStudio provided a deep insight into soil erosion and slope stability challenges. And through a data collection, simulation, and calculation, we address specific issues in the field slope along Tapalina Road, Albania. And recommendations include cavity, cantilever, embedded, and also reinforced soil retaining wall to mitigate erosion risk effectively. And GeoStudios provides a vital role in enhancing infrastructure resilience and environmental sustainability. And moving forward, we'll focus on research collaboration and best practices to manage the slope stability and also mitigate soil erosion risks effectively. And that concludes our presentation from Group 4. Thank you.